What's in a name? A lot, actually. The name Yann LeCun sounds very French, like a song from Brittany, that cool, rugged area in northwest France. The LeCun name hails from Brittany. It shows a background different from the rest of France. Its own language, its own ways. A history going back to the old Celts, who came from Great Britain. Yann was born near Paris in 1960, and he carried this Brittany spirit with him everywhere he goes, a minor aspect of who he is, but an absolutely imperative aspect to the development of who he has become. Maybe this link to an old, strong culture made him think for himself, wanting to go his own way instead of following everyone else. His early life was comfy in the French suburbs, and he was always curious. Growing up in quiet Soisy-sous-Montmorency, a town in Val d'Oise, a region approximately 7 miles or 11.5 kilometers north of Paris, France, young Yann wasn't clearly going to be a tech giant. He was just a smart kid, interested in how things worked. This was when the space race was happening and electronics were growing. The future felt super close, like you could almost build it yourself. His parents, both engineers, made a home where asking questions was good, and fixing things was important. This start, based on science and French common sense, would be the perfect push for a mind that would change our world. The France of his youth was a country caught between its long history and a fast-changing future. It was a place where you could study old books in the morning and dream of computer parts in the afternoon. There is a certain romance to the idea of the transatlantic journey, a pilgrimage made by countless dreamers and thinkers seeking new horizons. For Yann LeCun, the move to America was not an abandonment of his roots, but an expansion of them. It began with a post-doctoral fellowship at the University of Toronto under the tutelage of Geoffrey Hinton, considered by many as the Godfather of AI. His first taste of the North American research environment, a world of can-do optimism and academic dynamism. The experience opened his eyes to a different way of doing science, more collaborative and less hierarchical. Eventually it led him to the United States and Bell Labs in New Jersey. He arrived with formidable intellect and French sensibilities. That duality mattered. He embraced the scale and opportunities of American research while keeping a European skepticism and philosophical depth. Not assimilation, synthesis. He chose dual citizenship, France and the United States. It formalized an identity he had forged. He remains profoundly French in culture, in accent, and in his love of life's pleasures, and thoroughly American in professional ambition and belief in innovation. That dual identity gives him a unique global perspective. Insider in European tech, insider in American tech. Every great edifice is built upon a solid foundation, and for Yann LeCun, that foundation was laid in the esteemed halls of Parisian academia. His intellectual journey began in earnest at the ESYEE, Paris, an engineering school where he earned his diplôme d'ingénieur. This was not merely a course of study, but it was a deep immersion into the world of electronics and engineering, a place where theoretical knowledge was expected to find practical application. It was here that the abstract beauty of mathematics began to merge with the tangible reality of circuits and signals. He was learning the language of machines, the fundamental grammar that would allow him to one day teach them how to learn. The next crucial step was his doctoral work at the prestigious Université Pierre et Marie Curie, now part of the Sorbonne University, a university whose alumni and professors' accolades combined together have won more than 33 Nobel Prizes, 6 Fields Medals, and 1 Turing Award. It was during this period, in the mid-1980s, that he stumbled upon a concept that would define his career, the backpropagation algorithm. Working in the laboratory of Jean-Louis Laurier, LeCun independently rediscovered and refined this vital technique. Backpropagation is, in essence, a way for a neural network to learn from its mistakes. It's a method for adjusting the connections between artificial neurons, nudging the entire system closer and closer to the correct answer. It was the key that would unlock the potential of deep learning. His PhD thesis, a culmination of this groundbreaking work, laid out a vision for training neural networks that was far ahead of its time. If Paris was the crucible where Yann LeCun's ideas were forged, Then Bell Labs was the anvil where they were hammered into practical, world-changing shape. In 1988, he joined the storied research institution in Holmdel, New Jersey. Bell Labs was the cathedral of 20th century innovation, the transistor, the laser, the very fabric of the digital age. It was an environment that demanded ambitious ideas. Here LeCun was given the freedom and crucial resources to turn doctoral theories into reality. He found himself in a community of brilliant minds. A casual conversation in the canteen could spark a technological revolution. In this fertile environment, LeCun developed his most famous creation, the convolutional neural network, the CNN. Building on earlier work, he designed an elegant architecture named LeNet. The genius of LeNet was its structure inspired by the human visual cortex. It used layers of neurons that looked for simple features, edges, corners. Subsequent layers combined those features into complex patterns, shapes, numbers, letters. This hierarchical approach was revolutionary. It let the network learn features from raw data instead of requiring humans to program them. The first major test for LeNet was a practical problem: reading handwritten numbers, recognizing digits on bank checks, reading zip codes on mail envelopes for the US Postal Service. This was no trivial challenge. Handwriting is messy, variable, idiosyncratic. Yet LeNet 5, his most refined version, performed with astonishing accuracy. By the late 1990s, systems based on LeCun's CNNs processed a large share of checks cashed in the US. While convolutional neural networks were his signature contribution, Yann LeCun's innovative spirit was not confined to a single pursuit. During his tenure at AT&T Labs Research, the successor to Bell Labs, he co-developed a remarkable technology that solved a very different, yet equally important problem: how to make the vast repository of scanned documents and books accessible online. In the 1990s, the internet was growing, but bandwidth was still a precious commodity. High-resolution scanned pages were enormous files, making them impractical to download and view. The digital library was a wonderful dream, but honestly a logistical nightmare. Enter DjVu, pronounced DjVu. LeCun, Léon Bottou, and Patrick Hafner created a file format designed specifically for scanned documents. The technology was ingenious, cleverly segmenting a page image into different layers: background layer, foreground layer for text and drawings, mask to separate them. Each layer could then be compressed using the most efficient method for its content. The text, for instance, could be compressed much more tightly than the photographic background. This meant you could have a high-resolution, readable document at a fraction of the file size of formats like JPEG, TIFF. The impact of DjVu was immediate and profound. It became a key enabling technology for projects like the Internet Archive, which aimed to digitize millions of books and make them freely available. Without DjVu, this noble goal would have been far more difficult and expensive to achieve. It allowed libraries, universities, archives to put their collections online, preserving cultural heritage and democratizing access to knowledge. A brilliant algorithm is one thing, but for it to change the world, it needs to run on actual hardware. From the very beginning of his career, Yann LeCun understood this fundamental truth. The most elegant neural network is useless if it takes a year to train or requires a computer the size of a building to run. This deep appreciation for the interplay between software and hardware has been a constant thread throughout his work. During his time at Bell Labs, LeCun and his team didn't just write code for LeNet. They explored how to build specialized hardware to run it. They experimented with digital signal processors, DSPs, and even co-designed an early chip specifically for neural network computations. This was pioneering work. Decades before companies would pour billions into developing dedicated AI accelerators, LeCun was already on the case, trying to squeeze every last drop of performance out of the available technology. He knew that for his check-reading systems to be commercially viable, they had to be fast and efficient, and that meant thinking about the circuits themselves. After his foundational years in industrial research, Yann LeCun made a significant move back into the world of academia. In 2003, he joined New York University as a professor. He established a base in the vibrant intellectual hub of Greenwich Village. This wasn't a retreat from the real world, but a strategic decision to foster the next generation of AI talent. At NYU's current Institute of Mathematical Sciences, he created a world-class research group, the NYU Center for Data Science. His role as an educator is as central to his legacy as his inventions. As a professor, he has mentored dozens of students who have gone on to become leaders in the field themselves, founding their own startups, taking up key positions at major tech companies and universities. In 2013, a new chapter began. Mark Zuckerberg, recognizing the transformative potential of LeCun's work, persuaded him to become the founding director of the Facebook Artificial Intelligence Research Lab, now Meta AI. LeCun accepted on the condition that he could maintain his professorship at NYU and that the lab would operate with academic-style openness, publishing its research for all to see. In a world increasingly anxious about the rise of artificial intelligence, Yann LeCun stands as a powerful voice of reasoned optimism. While headlines buzz with dystopian scenarios of runaway superintelligence and robotic overlords, he offers a grounded, engineering-based perspective. He argues that the fear of AI achieving a malevolent, godlike consciousness is a fundamental misunderstanding of what we are actually building. He often points out that intelligence is not a single linear scale. Human intelligence is highly specialized. The systems we are creating are tools for specific purposes, not proto-life forms with their own desires and drives. LeCun firmly disagrees with the AI doom narrative, often engaging in spirited public debates with those who argue for pauses or heavy-handed regulation based on existential risk. His counter-argument is rooted in pragmatism, his vision. AI as an amplifier of human intelligence and creativity. He imagines everyone with an AI assistant that helps them learn, create, and navigate life's complexities. This isn't about replacing humans, it's about augmenting them. For LeCun, AI is the next great enabling technology. Like the printing press, like the internet, a tool to empower individuals and unlock progress. His optimism comes from deep hands-on understanding. He champions open-source AI, opposes concentration of power in a few corporations, and calls for accessibility for everyone. Openness, he believes, is the antidote to fear and misuse. By sharing code and knowledge, we build a global community of developers and researchers that can ensure safe, beneficial development. A career as transformative as Yann LeCun's does not go unnoticed. Over the decades, his office shelves have steadily filled with the highest honors science and technology can bestow. These awards are more than personal accolades. They are collective recognition by his peers. They are the official story of how a once niche area of computer science, championed by a small group of believers, came to dominate the 21st century. The pinnacle of this recognition came in 2018 when LeCun was awarded the Turing Award. Often described as the Nobel Prize of Computing, the Turing Award is the most prestigious honor in computer science. The citation celebrated their work conceptualizing and developing deep neural networks, the work that ignited the modern AI revolution. Beyond the Turing Award, his honors are long and distinguished. He's a member of the U.S. National Academy of Sciences. He is a member of the U.S. National Academy of Engineering. In France, he was made a Chevalier of the Legion of Honor. These laurels are not merely markers of past success. They provide him with a powerful platform. When a Turing laureate speaks, people listen. To understand Yann LeCun fully, one must look beyond the algorithms and accolades to the man himself. He is a figure of immense energy with varied passions, a multidimensional person beyond the computer lab. Those who know him speak of warmth, approachability, and a sharp Gallic wit. He is famously active on social media, engaging with colleagues, critics, and the public, sharing his latest research, debating AI policy, and occasionally posting sailing photos. This hobby seems a fitting metaphor for his work. Navigating the vast, unpredictable ocean of intelligence, trimming the sails to catch the winds of discovery. His role as a public intellectual and mentor is core to his identity. He feels a palpable responsibility to demystify AI and to guide the public conversation away from hype and fear toward a more nuanced understanding. Looking toward the future, LeCun's vision remains as ambitious as ever. His current research focuses on what he sees as the next major hurdle for AI. achieving human-level common sense. He is championing new architectures such as joint embedding predictive architectures, JEPA. These aim to teach models to understand the world like humans and animals do by observing, predicting, and building an internal model of how things work. He believes this is the key to creating AI systems that are more robust, more efficient, and more adaptable, moving beyond the limitations of today's large language models. Ultimately, Yann LeCun's legacy is that of an inspiring and relentless builder, from his early days in France to his dual roles at NYU and Meta. His career has been defined by a singular focus: to understand the principles of intelligence and to replicate them in machines. He is a scientist with the soul of an engineer, a theorist who insists on practical application, and an optimist who sees technology as a force for human empowerment. He laid the foundational stones of the modern AI era with his work on convolutional neural networks, and he continues to draw the architectural plans for its future. His story is a powerful reminder that a single, persistent vision can quite literally change the world forever,